everybody. Today we're going to talk about Pythagorean triples, and I want to tell you a few properties that you probably didn't know about. A lot of our study of trigonometry will be based on right triangles. Pythagorean triples are right triangles with integer values for all three sides of the triangle. That means that a squared plus b squared will be c squared. Knowing a few Pythagorean triples can speed up assignments by helping you avoid using the Pythagorean theorem. Some common Pythagorean triples you might want to memorize include 3, 4, 5, 5, 12, 13, and 8, 15, 17. These are the ones I see most in homework and quizzes because they're really small numbers that are easy to work with. There are also easy variations of these triples that I want you to start looking for. Any multiple of a Pythagorean triple will also be a Pythagorean triple. So say I take 3, 4, 5 and I multiply it by 2. I'll have 6, 8, 10. You could check it. 6 squared plus 8 squared will give you 10 squared. I could multiply 3, 4, 5 by 3 and have 9, 12, 15. Knowing the triples exist will help you start identifying them in problems. Let's say we have a right triangle with a hypotenuse of 25 and a height of 15. If we quickly factor those two numbers, we can see we have 5 times 5 and 3 times 5. Seeing the 3 and 5 tells me that the remaining side should be 4 times 5. That way I have my 3, 4, 5 Pythagorean triple and my constant 5 as the multiple. We know 4 times 5 is 20, so now we have our missing side, and we never had to square 15 or 25. Primitive Pythagorean triples do not have a factor common to all three terms. That goes back to our 3, 4, 5, 5, 12, 13, and 8, 15, 17. Be careful to note that primitive does not mean the numbers are prime. When I look at 5, 12, 13, 12 is not prime, or in 8, 15, 17, either 8 or 15 are prime. A few fun facts about primitive Pythagorean triples, where we're going to call the sides A, B, and C, where C is the hypotenuse, include that either A or B will always be even. That means A or B will be divisible by 2. One of them will be even, one of them will be odd. Either A or B will be divisible by 3. Either A or B will be divisible by 4, and either A, B, or C will be divisible by 5. So notice we went through 2, 3, 4, and 5. The last fun fact I'm going to put on the slide is that C will always be odd. But remember, this is only for primitive Pythagorean triples. Let's take the primitive Pythagorean triples we've talked about and see that this is always true. When I look at 3, 4, and 5, 4 is even, 3 is odd. 3 is divisible by 3, 4 is divisible by 4, and 5 is divisible by 5. 5 is also odd, so this was an easy one to check. Let's try 5, 12, 13. Looking at 5 and 12, 12 is even, 5 is odd. 12 is divisible by 3. 12 is also divisible by 4. 5 is divisible by 5, and our hypotenuse of 13 is odd. Let's try one more. I have 8, 15, 17. 8 is even, 15 is odd. 15 is divisible by 3. 8 is divisible by 4. 15 is divisible by 5, and our hypotenuse was once again odd. If you want to look at more primitive Pythagorean triples, I wrote all the triples up to 100 on this slide. There are many other primitive Pythagorean triples. In fact, there are infinitely many. Knowing the smaller ones like 3, 4, 5, 5, 12, 13, 8, 15, 17, and maybe even 7, 24, 25 will help as you study trigonometry.